Hi everyone, my name is Matt, also known as UKAstroNut, and today I'm just going to be going back through some of the particle stuff and the atom stuff that I did already. So I did a couple of videos before, but I came up with this really fun idea that I thought would try and make it a bit more kind of interactive. So I realised before I was just kind of using my hands so far and trying to describe things and just pinging numbers and stuff at you, but it's kind of nice if I could use some kind of visual way of representing things and stuff like this. So I came up with a fun way of doing this. I just so happened to have a box of Lego in my office, which I borrowed for some time. And so I'm going to try and explain particle physics and atoms and things like this using Lego, which sounds kind of a bit more fun, and also it's much actually easier to do because if you think about it, all the atoms and particles and everything are made of smaller things, and so Lego works really well by just combining these things together. And it can say, right, this block represents a proton, and then you can see that this block plus this block, a proton and neutron block, these together make an atom, and so on and so forth. So I thought I'd try to do this in a slightly more simple way. First things first, before I get onto the Lego, which is the fun part, which you're probably all here wanting to see, I'm just going to do another nice explanation of what the standard model of particle physics is. The standard model basically is an idea of the very most fundamental and elementary particles there are. So if you think about it, each particle, and this mug, okay, this mug is solid, okay. So the reason this is solid is because it's made up of a material. In this case, it's like porcelain or whatever mugs are made of. And then this is actually made up of atoms. So in this mug, there are billions and billions and billions of atoms, okay? And they all bond together. They all sort of stick together in a way, and they hold next to each other. So you have two atoms like this, and you have another one next to this, another one next to this, another one next to this, and then you have them all deep, so you have a really... So within this thickness of this mug, there's billions and billions of atoms, and they're all holding each other solid. It doesn't have to be the case that the tea in my mug is also made of atoms as well, but it's liquid, so the atoms aren't held together strongly, so they can move around each other like this. So materials and everything we have, water, gases, solids, they're all made of atoms, and they're all made of atoms that hold it together in different ways. So some are solid, some are liquid, some are gas, so on. So you have all these atoms, but then these atoms are made of components, which are the nucleus, which I did a video on already. If you haven't seen it, worth watching. And then you have electrons that go around the outside of this. So that's what an atom is. You have a nucleus of protons and neutrons, and then electrons around the outside. And as I said, all of these are loads of them, billions of them joined together, and they make your tea mug. But then each of these protons and neutrons are made of more particles. So if you can really zoom in to a proton, you see that it isn't just one blob that's stuck to a neutron like this, you don't have loads of them like this, but actually this is then made of 3 particles. And then we call these particles elementary particles. Along with the electron, we think that the electron, nothing makes up an electron, it's the basic thing. Okay, it builds everything else, but there's nothing that makes up it. But that's what we think. We haven't seen anything else, and so we think that these are the most basic particles, but we're not really sure. But this is why they're called elementary. So we have a list of elementary or fundamental particles, and they make up everything else, but we don't think that they're made of anything smaller. Okay, so I'll give you, as usual, my whiteboard, which is always useful for explaining things. So again, ignore this stuff for a second. So, as I said before, you have a material here. The material is made up of lots of atoms like this, and they're all held together, and they have all these little electrons, these little dots around the outside, and they're all held together strong. Or they're not, they're liquid, and they flow over each other, they're gas, and they all float around. But the material is made of lots of atoms. You have an atom here, and in the centre you have a nucleus made of protons and neutrons, and then around the outside you have these orbits, these electrons that are whizzing and whizzing around. Then, if we look closer at the nucleus, these little dots, little circles right in the centre, we see that actually they're made up of protons and neutrons in an atom. So these are held together as well, and these together, bonded together, held strong, form the central nucleus of an atom. But then again, if we look at one of the protons and neutrons, we find out these are actually made of even smaller particles. So protons and neutrons are made of 3 smaller particles here. Now I put N and P here for neutron and proton, and I've put U and D here. Now these particles are the more fundamental particles, as I said, and these are these particles here. So this is what's called the standard model of particle physics. So here what we have is you can imagine this in 3 sections here. So this column here is something called the force carriers. So the force carriers are basically things that carry force. So here we have for example, these two are to do with holding the particles inside an atom together. And this one here is a photon. So a photon is what light is. So when you see light from the sun, it's actually a stream of particles that are coming down, and each carry a bit of energy. So, I mean, when you're looking at anything, when you're looking at this whiteboard now, you can see it when you're looking at your screen, because your computer screen or your iPad is releasing photons, which are little bits of energy, little bits of light. They come into your eye, and then your brain recognises them and makes a nice picture for you. Up here we have the Higgs boson, which is a big thing at the moment. The Higgs boson is thought to hold all the mass of all the particles. So we think that the reason that these small particles actually have mass is they have some weight to them, is because of the Higgs boson. It's a bit confusing, but I'll definitely do a video on it and try to explain it as best I can. So along here, the bottom row, we have things called neutrinos, and these are very, very small particles, and they're released by things like the sun and things like this. They carry lots of energy. Along here we have electron, muon, tauon. These are small particles, and then along here, these 2 rows are particles that make up particles like this. They make up things called hadrons, which are things like protons and neutrons, basically. And there's lots of other ones. And these 6 things here, in different combinations, make up different particles, such as the proton and neutron. And these are up, down, charm, strange, top, bottom. These are a bit weirdly named at the centre, but they're just names, basically. There's nothing to do with anything. They're just random names. Okay? So this is the idea. Basically, you can build everything from just these. We've got 16 particles here. Actually, technically, I suppose these 12 kind of particles here, and these things all carry force. And we can build everything in the universe almost from these things. So it's really, really important. Obviously, they're vital for everything. And trying to understand them actually isn't that hard, especially if you have lots of Lego pieces. This. So I've come up with an idea of using Lego pieces to represent each of these particles here, and then I'll combine them together and show you how they make other particles. And I'll also carry on what I did with the nucleus one, and I'll still tell you loads of numbers and loads of facts and loads of really interesting things about particles, but also using the Lego bricks to kind of show how things are held together and everything. So thank you very much for watching. Don't forget to like, subscribe. I now have over 100 subscribers, which is crazy. So thank you very much everyone for watching, and the more subscribers I get, the more interest I'm going to be in doing videos and keeping up. I won't do it anyway, so it's fine, but tell people you know, leave comments, lots of questions and stuff. I really like answering questions, and if you have ideas of what videos you want to know, if you want to know how I don't know, how black holes form, then write it in the comments somewhere and I'll go, sure, okay, and I'll add to the list and I'll make a video and tell you guys how black holes form. So thank you very much. Keep an eye out for the next video. Next one will probably be on electrons, at least in this series anyway, and I'll tell you all about the electrons and everything. Thank you very much for watching, guys, and I'll see you guys soon.